Welcome to solving trig equation examples. So we're going to start where we started off in M4, which is how do I solve this equation? Where does the sine of theta equal the square root of 3 over 2? So in M4, what you did is you said, oh, sine, square root of 3 over 2, here and here. That makes sense because sine is positive in both quadrants. Therefore, the answer is pi thirds and 2 pi thirds. However, now we need to remember that we need all answers. So this value repeats at pi thirds plus 2 pi n. Pi thirds plus 2 pi n plus 2 pi n. Plus another 2 pi n plus another 2 pi n. So this repeats every 2 pi n. Similarly, this repeats every plus 2 pi n, plus 2 pi, plus 2 pi. So we have another plus 2 pi n. So now I have all solutions. So then we found, well, in M4, where's the tangent of theta equal to 1? You have to remember that tangent is the sine over the cosine. So where is sine over cosine a positive 1? That would be here, and down here when I have two negatives. So my answer would be pi fourths and 5 pi fourths. Let's talk about when these repeat. Well, this seems to repeat every half circle. That would be a pi. Oh, and another pi, pi, another pi. So I don't even need this answer. This repeats every pi n. Tangents tend to repeat every pi because the opposite quadrants, diagonal, pi away, tend to have the same values. So my answer to where is tan of theta equal to 1 would be pi fourths plus pi n. Where does the cosine equal positive 1/2? Cosine here, and positive 1/2 is down here. That does not repeat every pi n. These repeat every 2 pi n. So my answer would be pi thirds plus 2 pi n and 5 pi thirds plus 2 pi n. Where does the cosine of 2 theta equal square root of 3 over 2? This is confusing because there's a 2 theta. So the square root of 3 over 2 for cosine, let's ignore the 2 theta for now. Cosine of 2 pi equals square root of 3 over 2, positive. That means it's pi over 6, and it is 11 pi over 6. So 2 theta equals pi over 6. And 2 theta also equals 11 pi over 6. Both of these repeat every 2 pi n. This is the value of 2 theta that will give me this cosine value. I don't want a 2 theta, so I need to divide everything by 2. Everything by 2. Dividing by 2 is the same as multiplying by 1/2. Multiply by 1/2, multiply by 1/2, times 1/2, and times 1/2. Therefore, the value of theta that will make this equation equal square root of 3 over 2 would be pi twelfths plus pi n, and that's from this one, multiplying everything by 1/2, and 11 pi over 12 plus pi n. The most common thing to forget is to not to multiply this piece by the 1/2 as well. So let's get a little more logical. What am I going to do next? Well, for this one, for the first one, there's two different ways I could go about doing this. The first way is to factor, and the second way is to use the square roots. I'm going to factor because I love to factor. So I'll do that way with you first, then I'll show you square roots. I identify this as a difference of squares. 2 cosine minus 1, 2 cosine theta plus 1. Then I can set each factor equal to 0. When I solve this, I get cosine of theta equals 1/2. When I solve this, I get cosine of theta equals negative 1/2. So I need all the spots where cosine of theta equals 1/2 or negative 1/2. Here, 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 and here. So therefore, my answers are, well, do I need them all? That's where I need to see. This repeats diagonal, and this one repeats diagonal. So I can eliminate some of the answers by saying pi thirds plus pi n, because this one will repeat here, and then it'll continue to repeat. And my other answer would be 2 pi thirds plus pi n, which would be this first answer plus every pi it repeats. And that would be my answer. You could just have easily have substituted 5 pi thirds plus pi n. N is any integer, so it could be positive or negative. Similarly, this one you could have said 4 pi thirds plus pi n. You should not be duplicating answers and giving all 4. Okay, so remember that was my answer. And now I'm going to show you another method to get the same exact answer. So to get the same exact answer, I am going to simply say, get the one on the other side. So I have 4 cosine squared theta equals 1. Cosine squared theta equals 1/4. I'm going to square root both sides. Cosine theta equals plus or minus 1/2, because the square root of 1/4 is 1/2. So notice I'll get the same exact answers using either method. Now we're going to go on to another example. On this example, I can't just move the 3 to the other side. That won't help me, but I can factor. So when I factor this out using a box, grouping, however you factor, I end up with sine theta minus 3 and sine theta plus 1. I set each factor equal to 0, and I find that sine of theta equals 3 and sine of theta equals negative 1. Sine of theta can never equal 3, so I will not have an answer from that factor. I can, however, find when the sine of theta equals negative 1, and that would be here. So my answer would be 3 pi halves theta equals 3 pi halves plus 2 pi n. Since this is the only spot, repeats every full circle. Box my answers. So here, another kind of way that you could see the same sort of problems is verify that these are solutions. So it says, verify that when I sub this in for the secant, I get 0. In other words, check your answers. Wouldn't that be a wise thing to do? So I'm going to sub in secant of pi thirds minus 2 equals 0. So secant, I'm going to go back to my unit circle. Secant is associated with cosine. So let's look at pi thirds. Pi thirds is right here. And 1/2 is the cosine. If 1/2 is the cosine of pi thirds, then secant is going to be 2 over 1, which is 2. 2 minus 2 is 0. Yep, it works. Let's go similarly. Let's sub in 5 pi over 3. And let's see if that, when subtracted by, when 2 is subtracted from that, if it equals 0. 5 pi thirds is on your unit circle, is right here. There's the cosine value, which is 1/2. Cosine is still 1/2, so secant is still 2, and 2 minus 2 is still 0. Okay, let's solve this equation. Let's see if you can do this example. All right, now that you've tried it, I'm going to get sine x by itself. Sine x equals negative 1/2. I need to find where the sine value is negative 1/2. And that would be 7 pi over 6 and 11 pi over 6. And those both repeat every 2 pi n. So these would be my values of theta. Let's try another example. Try the tangent. Remember, tangent is sine over cosine. So now I will try the tangent. So I need to find where the tangent of x equals negative root 3. So sine over cosine. So I need to look on my chart on where the tangent, sine, is this numerator, and cosine is going to be 1. So sine, oops, this would give me a negative version of it. So sine over cosine, this, whoa, sorry. So this would give me negative root 3. And then down here, this would give me negative root 3. Therefore, my answer is 2 pi thirds and 5 pi thirds. Do I need them both? Nope, because they're diagonally across from each other. So I'm going to say 2 pi thirds plus pi n. You could just as easily have given me the answer, 5 pi thirds plus pi n. However, you should not be giving me both. Okay, so why don't you try solving this equation? Don't forget when you take square roots that it's a plus or minus. Now, I will solve. Tan squared x equals 1/3. So tan equals plus or minus 1 over root 3. I'm not rationalizing this because if I rationalize it, it's harder to find my values. Tan squared x equals 3. So tan x equals plus or minus root 3, which is over 1. So I'm looking for where the sine is 1, plus or minus, and the cosine is root 3. Sine is 1, and cosine is plus or minus. So that's here, here. Sorry, I screwed that up. Sine. Now I have to change my font. Sine is 1, negative root 3, here and here. Notice how these repeat across from each other, as do these. So from this side, I'm going to get pi over 6 plus pi n. That takes care of both of these answers. And then I'm going to get 5 pi over 6 plus pi n. That takes care of those answers. Now I'm going to continue with the right side of my problem. Make sure my pen is thin. And I'm going to find out where the sine is root 3 and the cosine is 1. That's what I tried to show you before. Plus or minus, so any version of positives or negatives would be all of these. Notice these repeat every pi n and these repeat every pi n. So my answer will be pi thirds plus pi n. That takes care of these two. And then I have 2 pi thirds plus pi n, and that takes care of these two. So these are all the solutions for theta. Now, find all solutions on the interval. This is no different, except that I don't add on plus 2 pi n. So let's begin. I want to know secant squared x equals 1. So when I square root, secant of x equals plus or minus 1. Secant is the same as 1 over cosine. So cosine of x, this is over 1, is plus or minus 1. Whereas cosine 1 or negative 1, that would be here or here. Notice how I am changing this problem slightly for you because I need to make a big block here. This means that you want to include 0 but not include 2 pi. If I had written my interval as such, it would mean I include 2 pi with a bracket and with a parentheses not include 0. Why does that matter? Because here I can word this particular location as 0 or 2 pi. Because of the interval, I'm going to call it 0, and this one is pi. I'm not attaching a plus pi n or plus 2 pi n because I don't want all answers. I want just the solutions in this range. So let's continue with this next example. On the next example, you try it, and now I'll do it for you. So I'm going to factor sine x plus 1. I'm going to set each factor equal to 0. And then I'm going to figure out where those sine values occur. Sine is negative 1 here, and sine is negative 1/2 here and here. I do not want all answers. I only want the ones on that interval. So I'm simply going to state the answers. 7 pi over 6, 3 pi over 2, and 11 pi over 6. And those are my answers. So if I were to find all solutions on this interval, I would find out where the sine is root 3 over 2. That would be here and here. So I have 2 pi thirds